Look at this simple circuit. When the resistor component swaps out for a larger one, the LED dims immediately. And if you use the wrong components, a part can even overheat and burn out. To understand why circuits behave this way, you need a rule called Ohm's law. In electrical work, this rule acts as the basic grammar of circuits. Once you know it, troubleshooting stops being a guessing game. These three icons represent our main characters. First is voltage, V, the electrical push moving charges, measured in volts. Second is current, I, the actual flow of electric charge, measured in amperes. Third is resistance, R, anything opposing that flow, measured in ohms. It all comes down to a simple balance. Voltage pushes, current flows, and resistance slows. Visualize this with a water pipe. The reservoir's pressure pushing the water acts exactly like voltage. The amount of flowing water represents current. If you pinch the pipe with a valve, acting as resistance, the flow physically slows down. Higher resistance directly reduces current. This physical reality translates into one mathematical formula. V equals I times R. Voltage equals current times resistance. Because these three values are locked together by this rule, knowing any two of them guarantees you can calculate the hidden third value. To make calculating missing values easier, use the Ohm's law triangle. Place V at the top, I and R at the bottom. To find voltage, cover V, leaving I times R. To find current, cover I, leaving V divided by R. Let's test this on a real circuit. We have a 12-volt battery and a 6-ohm resistor. We need to find the unknown current. Following our triangle, current equals voltage divided by resistance. 12 divided by 6 gives a final current of 2 amperes. Knowing that exact number is practical. If a circuit allows too much current to flow through a specific component, it will overheat and fail. Calculating this exact current beforehand prevents damaged parts and dangerous failures. Let's reverse the problem. In this circuit, we know the current is 0.5 amps, and the resistance is 20 ohms. The voltage is unknown. To find voltage, our formula is I times R. Multiplying 0.5 by 20 gives a required voltage of 10 volts. Now, pause the video and try one yourself. You have a 24-volt supply and an 8-ohm resistor. Calculate the current. To find current, we divide the 24 volts by the 8 ohms. The correct answer is B, 3 amps. A common operational mistake when calculating current is multiplying the voltage and resistance together instead of dividing. Remember, I equals V divided by R. When you are working on a lab bench, visualizing that triangle in your head is the best defense against making that error. In a technical training lab, like the ones at GMI, these calculations move off the whiteboard and onto the testing bench. You will use multimeters to measure these physical properties on real circuits. Technicians use Ohm's law as a mental framework to systematically isolate faults. When a machine control circuit fails, you check whether the correct voltage is supplied or if a faulty component has pushed the resistance too high. It all rests on this summary. Voltage pushes the charge, resistance limits it, and Ohm's law connects them. You can extract 3 variations of the formula. V equals I times R, I equals V divided by R, and R equals V divided by I. Before you finish, tackle these 3 capstone questions on your learning worksheet. For each one, identify the 2 known variables and calculate the missing third. Mastering this simple mathematical relationship is what takes you from someone looking at a broken circuit into a technician equipped to actually solve it.